All right, thank you very much. All right. Oh, wow. We'll see if I get the same level of applause after I'm done. It'll just be like, yeah. All right. So I'm going to be talking to you about TestClassMoose. Unfortunately, I think I might use up the whole time. So if we don't have time for questions at the end, I'll be at the conference. I will actually be here in Florida till Saturday morning. So anytime between now and then, feel free to come find me and ask questions. So, all right, let's talk about TestClassMoose and what problems it solves. So let's say you have a really big test suite. You have a lot of setup and teardown between each test script. And maybe you want to share test code between your tests. So you have different .t files, all of which are doing kind of the same stuff. A really common use might be, say, setting up database fixtures, something like that. And there's a lot of slowness in starting Perl over and over and over. So if you know how prove works, for example, what it does is it basically executes Perl blah, 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 .t. Now, I don't know if, Chad, you talked about Test2 harness, which actually has some ways you can avoid this. But you can also avoid it with TestClassMoose. And TestClassMoose provides a lot of other features for organizing your test code that go beyond just what a test harness can do. So you want to know more. It also has other features. So it has a reporting feature, which is actually really useful. You can get back a report at the end of your test telling you what passed, what ran, what passed, what was skipped. And another nice feature that I added recently-ish is you get timing data about all of the test stuff that was run. The test setup and teardown methods, as well as the actual test methods themselves. You can get a breakdown by method, by class, and then for the whole suite. And I didn't have a chance to show you an example, but I actually at work have put this together into building a flame graph for all of our test runs so we can see what takes a long time. And of course, you can write tests using Moose, which can be really useful. So here's a really simple test class. And the main things we see are, it's in a package. Now, most of you probably don't put your .t files in a package. This would be a .pm file. So it has a package. You can call it whatever you want. The convention that we've used at work, and which is in the TestClassMoose docs, which, by the way, I did not write TestClassMoose. I just worked on it a lot. It's created by Ovid, or Curtis Poe is his actual name. So the convention is to call it test4, : and then the class you're testing. We also have namespaces like test for integration, where we have integration tests that test more than just one class. And then the really key point, we have use TestClassMoose. That makes this a TestClassMoose test class. And then all our subs that start with test are test methods. Inside those subs, you just use the same stuff you would always use, whether that's test_more, which is automatically provided when you use TestClassMoose, or you can opt to not have it provide stuff, and you can use the Test2 suite if you want much better tools than what are in test_more. So you can use whatever you want. The point is, the method is named test something. That is your test method. So I think I already covered this. Any method starting with test underscore is a test method. You can also indicate to TestClassMoose that it's a test method with attributes, but Perl attributes are kind of crap. And a class can have many test methods. So you can have as many sub-test foo, test bar as you want in a single class. So because these test classes are also Moose classes, you can have attributes on those classes. So we can write, just like we would with Moose, has user, blah, blah, blah. And then inside our test methods, we can refer to those attributes. And this is where I was getting at the idea of if you want to do setup or some sort of shared state in your code, like let's say you're testing your user class and you want some methods for creating different types of users, it's very useful to be able to share that sort of stuff and refer to it in an object-oriented fashion. You can also use roles. So let's say we have a lot of model classes, all of which produce JSON output. Well, let's write a test role that tests our JSON producers, and presumably it provides some sort of method. Well, in our case, it'll be called test.json, and we can call that. And so all of our model classes, car, person, whatever, all of our test classes for our models, for testing car, testing person, whatever, can consume that one role and get access to this shared code. By the way, are people familiar with Moose roles? It looks like a good chunk. And I'm giving a class on Moose on Thursday if people are interested. There's also control methods. So I mentioned that you might want to do some sort of setup and teardown type stuff. So there's 4 control methods. There's test startup, which runs before anything in the class runs, before any of the test methods, but after the test class object is constructed. Test shutdown, which is the inverse, it runs right at the end after all the test methods are done. And then there's setup and teardown, which are run per method. So you can do a lot of different stuff with this, and it's also how you skip tests and things like that. So you could do your fixtures with using these control methods. So you could populate a database or files. We have tests at work. Some of our integration tests will start and stop external daemons doing this because we want to test, say, like we have a microservice-y framework where there's kind of an app service that talks to a kind of authorization service. Well, we have to start the authorization service, and we start and stop it for each test method because we want to make sure it's in a clean state. You could also put out extra diagnostic output if that's useful, and it's, as I mentioned, how you skip either an individual test method or an entire test class. So if you want to skip an entire class, you do it in test startup. That's the thing that runs per class, not per method. And you just write self-test skip, and you give it a reason, and then you return, and then TestClassMoose checks that that's populated. If it sees that it's populated, it will issue the skip message appropriately and abort. If you want to skip a method, it's very similar. You can get the current method being run from this test report object, and if the method is a certain name, then you do the same thing. You set test skip, and it just works. To-do tests are completely the same as they've always been. I just wanted to emphasize this, just in case people were wondering, well, is there a similar thing for do as there is for skip? It's not really necessary. You can just write the $to-do thing like you normally would. So how do you run these test classes? Well, you still need at least one .t file that the test, like prove or yet another yath, would execute. So this is kind of the simplest one you can write. You use TestClassMoose load. You point at a directory. It finds all the classes in there, all the test classes, loads them into memory. You create a runner, and you call run tests on the runner. Now, there's a whole bunch of options that you can pass to new there. There are other strategies you can use for loading the classes, but you could copy and paste this, and if you have a bunch of test classes in tlib, this will just work. Our test runner at work is like 300 lines because it does all this extra stuff that there's like different test configurations, and it does the saving of the timing data and all that stuff. But the point is you can do something really simple as well. So the way it figures out to run, it looks at the directory or directories you give it, and it finds everything. That's how it knows what to load. When you call run tests, it needs a way to figure out what to run. It basically looks at all the classes, all the Moose classes that have been loaded, and it just looks for ones that subclass TestClassMoose. When you use TestClassMoose, you become a subclass of TestClassMoose. At some point in the future, I might want to change that and offer a way to make being a test class a role rather than subclassing. Doesn't make a huge difference, but might be nice. You can also just choose to run some of the test classes if you want. So the new method for the runner accepts a test class's argument, which can be either a single string or an array ref containing strings, and those are class names. And if you give it that, it will only run those classes. You can also specify these things on the CLI if your .t file is designed to support that. So you write prove blah, 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 and then this thing, which for some reason is called an Aristotle, not Aristotle, but Aristotle with a D. I tried to figure out where this term comes from, and the only references I can find are to this. So I don't know. Anyway, any of the arguments after this 2 colons will not be seen by prove, but will instead be passed on to the file that prove executes. So you can look at argv inside your .t file, and if that's set, then you can pass that as test classes onto the runner. So I don't know. It just works, and it has a weird name. You can also run test classes in parallel. So if you just pass jobs to the constructor for TestClassMoose runner, if it's something other than 1, then it will run them in parallel. Right now, the parallel running is a little not ideal. There's just various bugs, and the reporting doesn't really work properly. I have a branch where I've essentially rewritten 90% of the internals of TestClassMoose to use Test2, and everything works really beautifully there. And I've released some trial releases, so if you want to try out parallel running with having everything working, there's a way to do that. I just am being a little cautious about releasing new stuff because there are some small behavioral changes that come with the Test2 changes. Actually have nothing to do with Test2, it's just changes I had to make while I was going. So there will be a stable release out probably later this summer. Anyway, you can run things in parallel, which is kind of cool. There's also a bunch of other test runner options. You could randomize the order that the methods in each class are run in. You can randomize the order that the classes are run in. By default, this stuff is all sorted. You can also specify methods to include or exclude, either by giving it a regex or a tag. A tag is like an attribute thing. You can also just do it by method name. So that can be really useful. Like if you have a giant test suite like we have at work with, I don't know, 300, 400, 500 test classes, and you just want to run one method in one test class to get some output, you don't really want to wait for the whole thing to run, which takes quite a while. So you can specify all that stuff on the command line, and then you change your .t file. You change the way it calls the runner constructor, and to pass these things along, and then it'll do what you want. So like I mentioned, there's this test reporting thing. It's a little broken for parallel tests. It's basically, it is an object returned by run tests. And like I mentioned at the beginning, it has a bunch of information about the test run, the pass, fail, skip status of basically everything in the test suite, and then how long each part of that took. Oh, that went way quicker than I thought. So I did this for my local Perl mongers group, and it took over 20 minutes. And I was like, oh man, I'm gonna have to go really fast here. I think maybe they interrupted me a lot. So let's see, what could I show you? Well, first I'll take questions, and then if we have more time, I'll try to find some code examples. Yeah?
So what made Test2 better? So you said you switched Test2 and that made things better?
Yeah, sure. So the question was, what made Test2, why was using Test2 better for the internals of TestClassMoose? So, all right. The way the pre-Test2 stuff worked, the only output of a test run was tap. Tap sent directly to both standard out and standard error. And that's problematic for quite a few reasons. Did you cover this in your talk, Chad?
I didn't get too much into it.
Okay.
Also, I never talked about Test2 harness. I completely forgot.
Oh, okay.
No one knows what he's saying.
Oh, okay. I'll try to mention what Test2 harness is after this then. Okay, so tap is defined as basically text going to standard out and standard error. It's hugely problematic for machine parsing for various reasons. And it's really easy for humans to read, like you've all seen it and you understand it. It's problematic for several reasons. First of all, the format is incredibly limited. Second of all, the way it uses both standard out and standard error is a freaking nightmare because you have to parse both streams, but yet standard error will also be used by, say, Perl to issue warnings. So then if you're trying to parse all this output, you're trying to parse random output that has nothing to do with tap and figure out where in the test stream of events it belongs, and mostly you guess and get it wrong. So if you're trying to do anything but just spit out tap to standard out and standard error, it's a real nightmare. Now, how does this affect TestClassMoose? Well, the parallel runner for TestClassMoose effectively works by forking off processes, capturing all their output, and then weaving it back together into a single stream of pod. Because keep in mind, sorry, tap, not pod. I was thinking of pod weaver for a second. Because keep in mind, we have one .t file being executed to run all of our test classes. They're running in parallel. We have to fit it all back together into proper tap. And we have to nest things properly because even though the test classes might not know they're in a subtest, from the parent process's perspective, they are in a subtest. And of course, another huge problem with tap is none of the parsers actually parse anything related to subtests. Everything that is indented in a tap stream is ignored. So it was just a huge nightmare for so many reasons. What TestClassMoose essentially had its own kind of mini tap parser and kind of tap streaming system that Ovid implemented just to deal with all this. Okay, so Test2 does this very differently. It passes events that are essentially Perl objects. Even when you have multiple processes, it's still, assuming you use the right kind of plugins and stuff for Test2, which Chad wrote as I was working on the Test2 stuff. I was like, hey, Chad, this isn't working. He's like, oh, right, I need to write this thing for you. So he wrote this thing that works really well. And from my perspective as the author of TestClassMoose, I don't actually care that anything is happening in separate processes or threads. It all comes back to one spot as a stream of events. And in fact, I don't even have to control that spot, so the hub in the Test2 speak, because I don't need to intercept any of this stuff anymore. Okay. The other thing that Test2 did was let me actually write some decent tests for TestClassMoose. Ironically, the tests were kind of terrible. The problem being, TestClassMoose admits a huge amount of subtests. There's basically one test at the top level, which is run all the test classes. So you get exactly one test from a typical tap parser. So if you want to know everything that happened in all your test classes that ran, you would have to parse all that to actually get information out. Now, there are some tools on CPAN for testing test modules that try to make this possible, and they don't work. They're just not quite good enough. I'll get to you in a second. So I was able to write a really nice test suite because with Test2, you can capture all the test events and then introspect them in your own test files. So I could say call run tests, intercept all the events, give me back the event stream, and then I can do very detailed tests on the event stream to make sure not just that the test classes passed, but they emitted exactly the output I wanted of nested subtests with pass or skip or whatever. Because it's really easy for the whole thing to pass, but to not have actually done what you wanted. So those two things were a huge improvement. Larry, you had a comment?
If we're already using TestClass, is TestClassMoose just a drop-in? Or?
So if you're using TestClass, is TestClassMoose a drop-in? Not quite. I think TestClass solely relies on attributes, if I remember correctly. I think, although maybe it's the same attributes, so maybe it would just work. I never used TestClass. We just started using TestClassMoose at work a few years ago, and before that we were using Ricardo's thing, test something or other. Test that thing that Ricardo wrote, which was kind of a very minimal test class type of thing. It was okay. It's not bad. It's just the more test modules we had, the more unwieldy it got because you need like a .t for each .pm. And that was getting really hairy, so it made more sense for us to switch to this. So I guess the answer is I'm not sure. Yes?
When I was watching the Test2 earlier, the diagnostics are exceptionally well done. And that goes over to using Test2 with TestMoose, we get those great diagnostic messages.
So the question was, he was saying he saw the Test2 Doc presentation before, and it had really good diagnostics. And does that also come with TestClassMoose? So the diagnostics are not coming from the core of Test2, which is really just the event system, which you can build any sort of testing tools on top of that you want to, including now TestMore and TestSimple are just built on top of Test2. So if you use those, you will get the output that those give, which I would assume has remained pretty much unchanged, because the whole point of Chad's work was to not change those. Now, if you want to use Test2, what is it, like Test2 Suite Extended? Yes, Test2 Bundle Extended, which has a whole bunch of Test2 modules bundled together with a whole bunch of plugins and nice output. You can use that with TestClassMoose. So you're not forced to use TestMore, but it's your choice. TestClassMoose is more of an executor of tests than rather as opposed to a tool for outputting test info. Does that make sense? So I was just told I have 1 minute left. So I just want to mention the thing that Chad forgot to mention, which is that there's this new thing called Test2 Harness, which essentially replaces proof with a new command line tool called Yath, yet another test harness, which apparently, based on the renaming of this conference, you should just call it Th. So anyway, it's a really nice tool. It's mostly drop-in replacement for Prove, now that you accepted my patches. But it has some nice additional features. First of all, he's telling me I'm done, but I'll just finish this answer. It has some really nice output that's much prettier than tap. And it also has a feature where you can preload modules and it will execute your test by forking rather than running exec perl blah 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 .t. It forks and then kind of, I think it uses do or something to load that test code in memory. So if you have something like Moose, for example, which has a slow startup time, or something that uses Moose that has a slow startup time, you can run Yath -L Moose T, and it'll run all the tests in T, but with Moose preloaded in memory, which for test suites that load a lot of modules and have a lot of .t files can result in a very significant speed up when you're running your test suite, which is really nice. All right, I'm out of time. Thank you very much. Thanks for all the questions.